Find the solution of the given initial value problem in explicit form and determine the interval in which the solution is defined. So let's solve this differential equation first. So we have dr over d theta equals r square over theta. Here r is dependent variable and theta is independent. R depends on theta. Let's separate the variables. So dr r square, let's bring it to the left side, r square, and d theta to the right hand side. So this will be 1 over r square dr equals, this is 1 over theta already in the right hand side, and d theta. Okay, just separate the variables. Next, integrate. Okay, entire derivative of 1 over r square, you're gonna move r square to the top. This becomes r to the negative 2. Okay, r to the negative 2, and use power rule, just x and dx. So this will be at the end negative 1 over r, and entire derivative of 1 over theta is just like 1 over x dx. So natural log of absolute theta plus c. Now before I solve this equation for r, we can solve for c. So using the initial condition, so using r at 1 equals 2, that means r is 2 when theta is 1. So using this given initial condition, we get negative 1 over r, r is 2, so negative 1/2 equals natural log of theta, theta is 1, and natural log of 1 is 0, plus c. So c equals negative 1/2. So c equals negative 1/2. Then the solution can be written as the solution, then negative 1 over r equals natural log of absolute theta plus c. C is negative 1/2. Okay, let's simplify this as a negative sign and as a bottom 2. So let's multiply through by negative 1 just to get rid of negative sign. Then this becomes 1 over r. This is now negative and this is positive, so I want to write positive first, 1/2, and this becomes minus natural log of absolute theta. And we need to solve this for r because the question wants us to write the solution in the explicit form. That means r equals some function of theta. Okay, so let's combine these two fractions in the right hand side to common denominator. So 1 minus 2 natural log of theta. Okay, now we can flip the fractions both sides, take the reciprocal of 1 over r, which is r, take the reciprocal, so we get 2 over 1 minus 2 natural log of theta. Okay, this is the explicit solution, by the way. So r is given as a function of theta. Now next we need to determine the interval in which the solution is defined. Okay, for this solution to be, this solution will be defined if the bottom is not equal to 0. Okay, the bottom should not be equal to 0 because some 2 divided by 0 is not good. Okay, let me write that over here. The solution is defined if the bottom 1 minus 2 natural log of absolute theta is not equal to 0. From this we will find the interval where theta lies. Okay, let's solve for theta. So move 1 to the other side, negative 2 natural log of theta should not be equal to negative 1. Divide by negative 2 both sides, so natural log of absolute theta should not be equal to negative 1 divided by negative 2, which is 1/2. Okay, should not be the case. Now exponentiate both sides so that we can get rid of this natural log. E and natural log cancel, so absolute theta should not be equal to e raised to 1/2. something raised to 1/2 means square root of e. That means when we get rid of this absolute value, theta should not be equal to plus or minus square root of e. Okay, and we can have any other values. At the same time, look, we have here the solution 1 minus 2 natural log of absolute theta, and natural log of 0 is undefined, so theta should not be 0 as well, and theta should not be 0 because natural log of theta is undefined. Okay, so theta should not be equal to plus or minus square root of e. Theta should not be equal to 0. That means theta can be any other values. So let's look at that in this number line. So this is theta, independent variable, negative infinity through positive infinity. So 0 here, negative square root of e, positive square root of e. So basically the solution exists in one of these 1, 2, 3, 4 intervals. Now we go back to the original question and see the initial value. R1 equals 2. So the initial condition is, let me write over here, R1 equals 2. Now we want to see where does this R lie in one of these 4 intervals. So square root of e is about 2.7, so square root of e is, I don't know, it's more than 1 obviously, so 1 is somewhere here. So this is the right interval. 1 lies here. So the interval where the solution exists is 0 through square root of e, because theta cannot be 0, theta cannot be square root of e, so we have to put in parentheses, not the bracket. Okay, final.